Hello, in this video I am going to perform wireless local area network, that is WLAN. The objective is to address the MAC layer of IEEE 802.11 standard for the wireless local area network. Various options of standard can build on various scenarios. There are two access methods in MAC sublayer: a distributed coordination function DCF, point coordination function PCF. DCF, it uses CSMA/CA. In DCF, every solution senses channel before transmitting data. If channel is empty, it waits for backoff interval time and then it again senses the channel, and if channel is empty, it starts data transmission. It is generally used in WLAN. PCF is a pooling process. In pooling, it asks a particular node if it wants to send data, then it sends data. It sends data transmission, and it is rarely used in WLAN process. Now let's come to the performance of the experiment. So there are four scenarios in this experiment: DCF, DCF fragmentation, PCF, DCF, PCF fragmentation. So first we are going to consider DCF. So for this experiment we are going to use 9 wireless LAN ADV tools to work on our project. So the first step we are going to perform is we have to change the name of each and every node. So go to edit attribute, change the name of the nodes, so make it node 0 for the first one. Go to traffic generation, go to wireless, change the wireless LAN MAC address to 0 as it's node 0, so it's easy to know the MAC address of each and every node. So if it is node 1, so make wireless LAN MAC address as 1 and destination address as a random for node 0. Yeah, that's it for the node 0. Now select another node, go to edit attributes, make it as node 1, make its MAC address as a 1 and select and assign a destination address to this node out of randomly you can assign any number, any node to send the data. Do all these things for the rest of the 7 nodes. Now select all the attributes, select all the nodes, go to edit attributes, under traffic generation parameters, make the start time. Start time is a time when application starts generating traffic. On state time is a time when application starts transmitting data, and off time is a time when the networks goes off state. And we have a packet generation argument here, and this packet size is a limit of packet size. So the packet size is a limit of packet size in the network we are going to sense, and when packets arise, if size is exceeded, then packets drop, and the packets are dropped. Yeah, and that's it. Make the changes for all the nodes. So we have selected all the nodes, so the changes will be reflected to each and every node. There's one more change under wireless LAN parameter. Make the buffer size as 46 like 8000, and then OK. Now we have to change global statistics. Inside the global statistics, wireless LAN, check the boxes of delay, load and throughput. inside global statistic, and under node statistics we have to check the boxes delay and retransmission attempts. So we are going to see these things in our results at the end. So the first scenario is done. So now we are going to switch to the next scenario, which is nothing but DCF fragmentation. DCF fragmentation is an DCF fragmentation. Here packet is converted into fragments and then it uses the DCF process. So select similar nodes, go to edit attributes, under wireless LAN, go to wireless LAN properties, and then wireless LAN properties. Make the fragment threshold as a 256 bytes. It means if the packet exceeds 256 bytes, then that packet will convert it into fragments, and then it will transmit the data into the network. So click on OK. Since it is a duplicate of DCF, so we don't have to change all any other things. For the fragmentation, we have done the changes. So now we will switch to the next scenario, which is DCF PCF. So DCF PCF is also a duplicate of DCF. So we don't have to change its configuration for the DCF. We have to change its configuration for PCF only. So for this we have to change the configuration for node 0, node 1, 3, then 5, then 7. Right click on any node which we have selected, go to edit attributes, go to wireless LAN, under wireless LAN parameters, go to PCF parameters and make this PCF functionality enabled, then click on OK. Yeah, that's it. Yeah, so that's it for this scenario. Now we are going to do the last scenario, which is DCF PCF fragmentation. DCF PCF fragmentation is a duplicate of DCF fragmentation. We need to enable the PCF fragmentation. So similarly we have to select all the nodes. We have to change the under wireless LAN parameters, PCF parameters, make the PCF functionality as enable and then click on OK. So that's it. We have covered all the 4 scenarios in our project. So now we are going to see the results of this. So we are going under result section, we are going to compare result, and now we have to select all these things. So under global statistics, under wireless LAN, so delay in this, the for the first 2 scenarios, for the DCF for the DCF and the DCF fragmentation, there is no delay, and for the other 2 scenarios, that is DCF PCF and DCF PCF fragmentation, there is a delay. So the graph is in the graph there is an ups and downs. There is no for the first 2 scenarios, the graph shows the constant line. Now we are going to show for the load. So for all the scenarios we have almost similar type of graph. For throughput, same, we have all the for all the scenarios we have the same graph. That's it. Yeah. Thank you.